students, today we will talk about movements in the ocean water. So let's start it with a simplified way. The ocean water is dynamic. Its physical characteristics like temperature, salinity, density and the external forces like sun, moon and the winds influence the movement in the ocean water. The horizontal as well as vertical motions are common in ocean water. The horizontal motion refers to the ocean currents and waves, while the vertical motion refers to tides. The ocean currents are the continuous flow of huge amount of water in the definite direction, while the waves are the horizontal motion of water. In the ocean currents moves ahead while the water in the waves does not move. The vertical motion refers to the rise and fall in the water, ocean or the sea due to the attraction of sun and the moon. The upwelling and sinking are also vertical movements. The upwelling means water move from below to upside and sinking means water go down from the sea surface to the bottom. So let me start with some keywords. The highest and the lowest points of the wave are called as crest and trough respectively. The wave height is the vertical distance from the bottom of a trough to the top of a crest. Wave amplitude is one half of the wave height. Wave period is merely the time interval between the two successive waves. Crest or troughs as the key pass a fixed point. Wavelength is the horizontal distance between two successive crests. And wave speed is the rate at which wave moves through the water and is measured in knots. Now we have frequency. Wave frequency is the number of wave passing a given point in 1 second. Waves and their characteristics. Waves are actually the energy, not the water as such, which moves across the ocean surface. Water particles only travel in a small circle as a wave passes. Wind provides energy to the waves. Wind causes waves to travel in the ocean and the energy is released on the shorelines. The motion of the surface water seldom affects the stagnant deep bottom water of the oceans. As a wave approaches the beach, it slows down. This is due to the friction occurring between the dynamic water and the sea floor. The largest waves are found in the open oceans. Waves continue to grow larger as they move and absorb energy from the wind. When a cool breeze of 2 or less than 2 knots blows over the calm water, small ripples form and grow as the wind speed increases until white caps appear in the breaking waves. Waves are traveled thousands of kilometers before rolling to shore. Breaking and dissolving as surf, the origin of wave is revealed by its size and shape. Steep waves are fairly young ones and are probably formed by local winds. Slow and steady waves originate from far away places, possibly from the another hemisphere. Now we will talk about the maximum wave height is determined by the strength of the wind, that is how long it blows and the area over which it blows is a single direction. Waves travel because wind pushes the water body in its course, while gravity pulls the crest of the waves downward. The actual motion of the water beneath the waves is circular. Now tides. Tides can be defined as periodical rise and fall in the sea level, once or twice a day, mainly due to the attraction of sun and the moon. This is called as tide. Movement of water caused by meteorological effects like wind and atmospheric pressure are called as surge. Surges are not regular like tides. The study of tides is very complex, spatially and temporally, as it has great variations in frequency, magnitude and height. Mainly the motion's gravitational pull to a lesser extent and the sun's gravitational pull are the major causes of tides. Another factor is centrifugal force, which is the force that acts to counterbalance the gravity. Together, gravitational pull and the centrifugal force are responsible for creating the two major tidal bulges on the earth. One bulge on the side of the earth facing the moon, a tidal occurs, while on the opposite side moon attraction is less, but because of the centrifugal force, tidal bulge occurs on the other side also. The tidal bulges on one continental shelves have greater height. When tidal bulges hit the mid-oceanic islands, they become low. The shape of the bays and estuaries, which are mouth of the river along a coastline, can also magnify the intensity of tides. Funnel-shaped bays greatly change tidal magnitudes. When the tide is channeled between islands or into bays and estuaries, they are called as tidal currents. Example of tides in the Bay of Fundy, which is in the Canada. The highest tides in the world occur in the Bay of Fundy, which is Nova Scotia in Canada. The tidal bulge is 15 to 16 meter, you can assume 15 to 16 meter, because there are 2 high tides and 2 low tides every day, roughly in 24 hours of time. If you have walked down a beach with a steep cliff alongside, make sure you watch a tide. If you walk for about an hour and then notice that the tide is coming in, the water will be over your head before you get back to where you started. Now we will talk about types of tides vary in their frequency, direction and movement. Classification of tides based on frequency. The first is diurnal tide, when there is only one high tide and one low tide during each day. Now semi-diurnal tide, it means when 2 high tides and 2 low tides occur each day. Mixed tide, this kind of tides having variations in the height are known as mixed tides. These tides generally occur along the west coast of North America and on many islands of the Pacific Ocean. Now the classification is based on sun, moon and earth's position. The height of the rising water varies appreciably depending upon the position of sun and the moon with respect to earth. Spring tides, when the sun, the moon and the earth are in straight line, the height of the tide will be higher. They occur twice a month, one at a time of full moon and another at a time of new moon. Neap tides, it occurs when the sun and the moon are at the right angle to each other and the forces of the sun and moon tend to counteract one another. The moon's attraction is twice to sun's gravitational pull. Right angle can be defined as like earth position is here, moon position is here and sun position is here. So this kind of right angle. Once in a month, when the moon's orbit is closest to the earth, that is called perigee, usually high and low tide occur. 2 weeks later, when the moon is farthest from the earth, that is called apogee, the moon's gravitational force is limited, so small height tide occurs. When the earth is closest to the sun, that is perihelion, at the time of 3rd January, each year tidal ranges are also much greater with usually high and unusually low tides. When the earth is farthest from the sun, that is aphelion, around the 4th July, each year tidal ranges are much less than average. The time between the high tide and the low tide when the water level is falling is called as ebb. The time between the low tide and the high tide when the tide is rising is called as flow or flood. Now we will talk about importance of tides. Since tides are caused by the earth, moon, sun positions which are known accurately, the tides can be predicted well in advance. This helps the navigators and fishermen plan their activities. Tidal flows are of great importance for navigation. Tidal heights are very important, especially harbors, near rivers and within estuaries having shallow bars at the entrance which prevent the ships to and boat from entering into the harbor. Tides are also helpful in desilting the sediments and in removing polluted water from the river estuaries. Tides are used to generate electrical power in the countries like Canada, France, Russia and China. A 3 megawatt tidal power project at Durgadhuni in Sundarbans of West Bengal is also under construction. Now we will talk about ocean currents. Ocean currents are like river flow in the oceans. They represent a regular volume of water in a definite path and direction. Ocean currents are influenced by the following factors. Number 1, heating by solar energy. Next is wind, gravity, Coriolis force, etc. Due to the heating, water expand, and because of the nearness of the equator, the ocean water is about 8 centimeter higher in level than to the mid latitudes. This causes a very slight gradient and water tends to flow from equator towards pole. When wind blowing on the surface of the ocean pushes the water to move, friction between the wind and the water surface affects the movement of the water body in its course. Gravity tends to pull the water down the pile and create gradient variation. Coriolis force intervenes and causes the water to move to the right in the northern hemisphere and to the left in the southern hemisphere. These large accumulations of water and the flow around them is called as gyres, which produce large circular currents in all the ocean basins. Water with the high salinity is denser than water with low salinity, and in the same way cold water is denser than warm water. Denser water tends to sink while relatively lighter water tends to rise. Cold water ocean currents occur when the cold current at the pole sinks and slowly moves towards the equator. Warm water currents travel from equator towards pole to replace the sinking cold water. Now we will talk about characteristics of the ocean currents. Currents are referred by their drift, which measures in knots. Usually the currents are strongest near the surface and may attain speeds over 5 knots. At depths, currents are generally slow with speed less than 0.5 knots. We refer to the speed of current as its drift. The strength of a current refers to the speed of the current. A fast current is considered strong. A current is usually strongest at the surface and decrease its strength with depth. Most currents have speed less than or equal to 5 knots. Types of ocean currents. The ocean currents may be classified based on their depth as surface currents and deep water currents. Surface water currents constitute about 10% of the all over water in the ocean, and these waters are upper 400 meter of the ocean. The deep water currents make up to the 90% of the ocean water. These waters move around the ocean basins due to variations in the density and gravity. Deep waters sink into the deep oceans basins at high latitudes where the temperatures are cold enough to cause the density to increase. Ocean currents can also be classified based on temperature as cold currents and warm currents. Cold currents bring cold water into the warm water areas, while these currents are usually found on the west coast of the continents in the low and middle latitudes, and on the east coast in the higher latitudes in the northern hemisphere. Warm currents bring warm water into cold water areas and are usually observed on the east coast of continents in the low and mid latitudes in both the hemispheres. In the northern hemisphere, they are found on the west coast of the continents in the high latitudes. Major ocean currents. Major ocean currents are greatly influenced by stresses exerted by the prevailing winds and Coriolis force. The air circulation over the oceans in the middle latitudes is mainly anticyclonic, and it is more dominant or pronounced in the southern hemisphere than in the northern hemisphere. At higher latitudes, where the wind flow is mostly cyclonic and ocean circulation follows this pattern, in regions of pronounced monsoonal flow, the monsoon winds influence the current movements in the oceans. Due to the Coriolis force, the warm currents from low latitudes tend to move to the right in the northern hemisphere and to their left in the southern hemisphere. The oceanic circulation transports heat from one latitude belt to the another in a manner similar to the heat transported by the general circulation of the atmosphere. The cold waters of the Arctic and Antarctic circles move towards warmer water in tropical and equatorial regions, while the warm waters of the lower latitudes move poleward. The major currents in the different oceans are shown in the figure 14.3. Effects of the ocean currents. Under the effects, ocean currents have a number of direct and indirect influences on the human activities. West coast of the continents in tropical and subtropical latitudes are bordered by cool waters. Their average temperature are relatively low with the narrow diurnal and annual ranges. There is fog, but generally the areas are arid. West coast of the continents in the middle and higher latitudes are bordered by warm waters, which cause a distinct marine climate. Means they create different kind of climate there. They are characterized by cool summers and relatively mild winters with a narrow annual range of temperatures. Warm currents flow parallel to east coast of the continents in tropical and subtropical latitudes. This results in warm and rainy climates. There lie in the western margins of the subtropical anticyclones. The mixing of warm and cold currents help to replenish the oxygen and favor the growth of plankton, the primary food of fish population. The best fishing grounds of the world exist mainly in these mixing zones of warm and cold currents. So, this is what we talked about ocean waters and movement, salinity and temperature, which are the factors of impacting the ocean currents. So, thank you very much. Thanks.